Hello and welcome. Today we're going to build a real JSON parser from scratch in 10 minutes. We'll have zero dependencies and we won't use regular expressions. So how can we do it? We're going to start by setting up our basic types. The primitive type we're going to have is a JSON value, which is a union of a JSON object, a JSON array, and some basic scalar types like an int or a string. For those that aren't familiar, Python allows us to declare recursive types by passing in a type name as a string. Next, we define a JSON object type, which is a dictionary keyed by a string, and the values are JSON values. Similarly, JSON array is a list of JSON values. Now we're going to set up the basic entry point for our parser, which is a function that takes in a string input and returns a JSON value. Before we implement parse, we're going to want to implement a scanner class, more commonly called a lexer. This will take a sequence of characters and return a sequence of high-level tokens that the parser can more easily work with. I like to think of it a little bit like Pac-Man, eating a sequence of characters and pooping out some tokens. We're going to need tokens for the basic data types: strings, numbers, booleans, and null. Next, we're going to add tokens for all the various kinds of punctuation like brackets. We'll also add a special token to signify the end of file. Now we're ready to implement the token class, which takes in the token type and the value which the token itself holds. The scanner will work by maintaining a list of all tokens processed, the index of the start of the current token, and the index of the current character to be processed. We'll also keep track of the line number, which will make debugging a lot easier. The scan method will then return this list of tokens. We'll implement scan by looping until we've consumed all characters, scanning tokens one by one. Each time, we'll set the start of the current token to the current position in the source string. Once we've consumed the source string, we'll add an end of file token to communicate to the parser there are no more tokens. Finally, we'll return the list of tokens that we've built up. We'll implement the helper function isAttend by checking to see if the index of the current character has overrun the length of the string. It's worth pausing for a moment to discuss some of the utility functions we're going to be using in our scanner. isAttend returns true or false whether or not we have consumed the source input. Advance returns the current character and advances the current character index by 1. Peek returns the current character without advancing the index, and peek next returns the next character. At a higher level, our scanner consists of a scan token method, which will further call an add string, add number, or add keyword method whenever the corresponding token is encountered. With all that said, let's go ahead and implement the scan token method. We'll call our advance helper method to return the current character. We'll then use Python's match statement to match the current character. For each of the punctuation tokens, this is very straightforward. Each character is one token. When we hit a new line, we'll increment the line counter by 1. And in the case of white space, we'll skip over it and do nothing. If we hit a quotation, we'll then call a helper method add string. When we hit a minus sign, we'll want to call peek to check that the next character is a digit so that we can safely add a number token. Note that I mistakenly used peek next here instead of peek, and I found this bug while editing the video. In the case that it is a digit, we'll call the advance method to advance the character counter index, and we'll call the add number method. Otherwise, we'll raise a value error to say that a minus sign must be followed by a number. Lastly, we'll check if the character is a digit, and if it is, we'll call the add number method. Else, if the character is an alpha character, we'll call the add keyword method. Otherwise, we'll raise a value error to declare this an unexpected token, passing in the current line number to help us locate the offending character. Now we can implement our advance method, which returns the current character and increases the current index by 1. Add string works by iterating through the input until it finds a closing quote or the end of the file. If neither is found, it advances the counter. If the end of the file is found before the closing quote, we raise an exception to declare that the string was not terminated. Finally, we advance the scanner once more to consume the closing quote. We then add the string token to the list of tokens, being careful with our indices to strip off the enclosing quotes. Add number advances through the input until it finds a non-digit character. It peeks to see if it's a period, in which case we may be parsing a float. It calls peek next to see if it's a digit, and if so, it assumes it's a float. Otherwise, it raises an error declaring that a number must come after the period. It consumes the period and then advances through the remaining digits. In the float case, we use Python's built-in float method to parse the string into a float, and likewise for int we use the Python's built-in int method. Our final high-level token method is add keyword, which consumes all the characters until it finds a non-alpha character. It then matches the string against true, false, or null. In the case of true or false, we append a Boolean token with the corresponding value. When null, we append a null token with the non-value. Lastly, if there isn't a keyword match, we raise an unexpected token error. Phew, we're almost done. Now all that remains is to implement the peek and peek next functions. For peek, we check to see if we are at the end of the string, and if so, we return the empty string. Otherwise, we will return the current character. For peek next, we check to make sure that there's enough space in the string for the next character. If not, again, we return an empty string. Otherwise, we return the next character. And with that, we finished our scanner. Well done for making it this far. We're now ready to go back to our parser with our newly built scanner. Before we do though, it would mean the world to me if you could like this video, and if you haven't already, hit that subscribe button. This is my first video on YouTube and I want to make high quality educational content. If you subscribe, it lets me know that I'm doing something right. Please also let me know in the comments below what you think I could do better. Now we can go ahead and implement the parse function from earlier. We'll construct a scanner and a list of tokens by calling the scan method. We're going to create a parser class, because like scanner, we're going to need to keep track of some state. We'll then call the parse method on the parser class. Before we go ahead and implement the parser, let's pause for a moment to look ahead at what we're going to implement. We're going to have a parse method which returns a JSON value and a helper parse from token which parses out a value from a given token. This helper method will be used by the entry point parse method as well as parse object and parse array. Parse object is responsible for returning a JSON object type and parse array is responsible for returning a JSON array type. Just as in scanner, we'll have advance and peek methods, and instead of returning a character, they will return a token. This time, we'll add a consume helper method, which allows us to assert that the current token is an expected token, allowing us to enforce the grammar of JSON. We'll initialize the parser class with a list of tokens and the current token index. The parse method will advance the current token and call the parse from token method on the returned token. Parse from token will match on the token type, and in the case of a scalar, it will return the value of the token. If the token is a left brace, we'll call the parse object helper method. And similarly, if the token is a left bracket, we'll call the parse array helper method. Lastly, if we hit any other token at this point, we'll raise an unexpected token error. We'll implement parse object by initializing the return value to an empty dictionary. We'll iterate through all the keys in the object until we hit a right brace, signifying we have hit the end of the object. We'll then perform some validation checks on the key. If we hit an end of file, we'll raise an error to declare we have an unterminated JSON object, and we'll check to make sure the key is a string token. After that, we'll consume the colon token, throwing an error if the next token is anything else. We then grab the first token of the value and recursively call our parse from token method, setting the return value to the value of our key token in the return JSON object we initialized earlier. We then try to consume a comma, unless the next token is a right brace. We advance the token again and continue to loop until we hit the end of the JSON object. Parse array works similarly. We'll initialize the return value to an empty list and advance through the token until we hit a right bracket. We'll check to make sure we haven't hit the end of file, and if we do, we'll raise an error. We'll then parse the token into a JSON value and append it to the return value. We'll consume a comma unless the next token is a right bracket, and we continue the loop. Implementing advance is much the same as it was in scanner. We return the current token and advance the current token index by 1. Consume calls peek and checks to see if the current token type matches the expected token type. Otherwise, it raises an exception with the error message supplied by the caller. We then advance the current token index once more. Consume comma unless peeks at the current token and advances the token index if it encounters a comma. Otherwise, it checks to make sure the token is an allowed exception like a right brace or a right bracket. Note that in this implementation, we simplify the code a little by allowing trailing commas in objects and arrays. Finally, we implement peek by returning the current token. And with that, in just under 250 lines of code or so, we've implemented a fully functioning JSON parser. Before we finish, let's take the parser for a little test drive. We'll open up Python and import our parse function. We'll pass in a list of a float, null, true, an int, a list, and an object. We can see that it correctly returns a Python list of the corresponding types. Floats and ints are handled correctly, null is mapped to none, arrays are mapped to lists, and objects are mapped to dictionaries. This is the same as the Python standard library's JSON.loads function. Thank you so much for watching. This JSON parser has some small gaps. For example, it doesn't handle all white space, Unicode escape sequences, and numbers in exponent format. If you'd like to, you can clone the code from my GitHub, link in the description, and try to implement some of these gaps yourself. Otherwise, please consider following on GitHub or X. Have a nice day.